So this is our first problem in the test review. We've got y equals tangent of the arcsine of x over 2, and we're going to find y prime in terms of x. This one I need the triangle, okay? I'm thinking you need the triangle at least once, maybe twice on your exam. I'm trying to leave it to 7 questions again. I am going to repeat at least a question from the first exam, right? So, and we basically did a review on Tuesday as well, and that's fine with me. In fact, when we, because we're completely caught up, the other classes as well. So we'll all just start chapter 4 at the same time when we come back from break, right? So anyway, this one I need the triangle. So what's hinting to me that I can see a triangle here is that I have an inverse trig. So whenever I have an inverse trig, I'm thinking of an angle, right? So this is the arcsine of x over 2. But I don't like to think in terms of inverse trigs. I like to think in terms of trigs. So I take the sine of both sides. And on the right-hand side, they're inverse functions, so they cancel. So I get sine of theta is x over 2. And that's giving me my right triangle, right? That will tell me my right triangle because now all of a sudden I have a ratio. So sine is opposite over hypotenuse, and the remaining side will come from Pythagorean theorem, square root of 4 minus x squared. Is everybody okay here? Udi is still not here. Is that correct? Yes. Okay. So, oh, there he is. Beautiful. Morning, Udi.
Good morning.
You get your lockdown browser to work?
So far it works. I'm going to try it again just to make sure there's anything wrong.
Oh no, yeah. Udi, Caitlin, I saw you give me a thumbs up earlier, so thank you. Udi, is your lockdown browser work?
Not yet. I'm about to see it today.
Okay. Please. Okay. So now that I have some background information on what I'm going to, right? Because I know when I take a derivative of tangent, I'm going to get a secant squared, right? I'm going to have to get that solution from the triangle. I'm going to have to get that in terms of x's from the triangle. And this happens again in Calc 2. For sometimes we're trying to undo derivatives, and we've got to take trigs and turn them into x's. And sometimes we have to take x's and turn them into trigs, okay? So it's an important thing to be able to do here. So I'm ready to take my derivative, right? And I've got y equals tan of theta is what I might as well think about. But I'm taking my derivative in terms of x's, right? d dx of tan of theta should equal d dx of y. I guess I did that a little backward, but it's okay, right? So you can see I'm doing implicit really here, right? Because I'm doing a derivative of x, but I don't have any x's in here, right? I've got a y and I've got a theta. So what do I get? I get y prime is equal secant squared theta times theta prime. Is everybody with me there? Nice. But theta prime, right, is the arcsine of x over 2 prime. And for that one, I have a formula, right? On my formula sheet, I have a formula, right? Everybody's got their formula sheet done or close to done. Yes? So what's my formula sheet say? It says if y equals arcsine of x, of u, y prime is u prime over the square root of 1 minus u squared, right? I want to be thinking about that version of the derivative when I have a complicated inside, right? Always thinking of the chain rule version of whatever I have. So I really need another piece of side work here. I need to figure out what u is. Who's got it?
2.
Yeah, x over 2. So u prime is, what's the slope of x over 2? 1/2. And u squared is x squared over 4. Right? Remember, y equals x over 2 is y equals 1/2 x. It's an mx plus b, right? So there's my side work to get that part of the derivative. So here we go, back to the problem. Y prime is secant squared theta times 1/2 over the square root of 1 minus x squared over 4. Delilah, how's everything here? This is the question you asked me about. You feeling okay here?
For the u prime,
Yes.
could you just like go repeat that again?
Yes.
Like the
So
process.
if I have y equals x over 2, right, that might as well be y equals 1/2 x plus 0. So I can really see the mx plus b. So derivative is 1/2. Really simple.
Okay, that makes more sense.
It's always this way for us humans, is when something's so simple that we don't have to do something, we think we have to do something, right? It's pretty typical. Now, I'm close. I definitely see I have fractions within fractions, so I know I have to clean that up. But I need to get my secant squared theta from the triangle, right? Just a reminder of the triangle. I had x, I had a 2, I had a square root of 4 minus x squared. So the secant's going to come from that piece, right? So secant is 2 over square roots of 4 minus x squared, but squared, right? It's secant squared, times 1/2 over square root of 1 minus x squared over 4. So I got some simplifying to do. I know I'm going to have to get rid of the fractions within fractions. So I need an LCD here. So I'm going to multiply by 4 over 4 here. How's everybody?
Exactly the same as Monday for me.
Okay, I hope that's a good thing.
Well, yeah, because this question is from Monday, so that is good.
Yeah, that's good. So if you can do this one, you can do the one that's on the test. But I'm going to change it. What am I going to change? What am I going to change from? Yeah, variable will change. So it won't be an x over 2. It'll be something else. What else could I change?
You could make it like arc cosine.
Exactly. The inverse trig will change, but it will only be arc sine, arc cosine, or arc tan. And what else could change?
The outside function.
The outside function. It's going to be any of the 6 trigs. Sine, cosine, tangent, cosecant, secant, cotangent.
And actually, for really, can you go over the what the inverse trigs are going to equal for y prime? So you have inverse sine already.
Yeah, we know inverse. We know all of them, right? Didn't I ask you to do the last one on your own?
Oh, that's right. Okay, I'll get that.
It's in the book, but I'll write it down today. I don't mind doing that. Let's keep going here. So I've got 4 over 4 minus x squared. That 4 looks a little funky, right? And then I've got 1/2 over the square root of 4 minus x squared over 4, right? I got an LCD down in that radical. So that 4 can come out of the radical, right? Does that make sense? So 4 and 1/2 is well, let me not do that yet. So I've still got 4 over 4 minus x squared. I can. And in fact, you don't have to do your algebra the way I do mine. You don't have to do your arithmetic the way I do mine. You just got to do it correctly. And so I still have a 1/2 over square root of 4 minus x squared. But that 4 came out as a 1/2, right? Square root of 4 is 2. So square root of 1 over 4 is 1/2. And now I can see that these 1/2s cancel. Is everybody okay there? So y prime is 4 over 4 minus x squared, all to the 3/2. And there's a nice answer. So we're just trying to get a single term completely factored. So if it's a fraction, factored in the numerator, factored in the denominator. Delilah, is that okay?
Yeah, that makes sense now.
Nice. Let's before I answer Afsoon's question, let me do those 3 inverse trig derivatives real quick, okay? Just because it's a good time to do them, right? So, I mean, I don't think you need both versions on your formula sheet, right? But I'll put them both. The first one we derived, was the arctan of x, right? If y equals arctan of x, we got y prime is 1 over 1 plus x squared. And then we said, well, we better think about it with the chain rule, right? So if I have arctan of u, right, then I'm thinking y prime is u prime over 1 plus u squared. So you can certainly see what's the difference. 1 over 1 plus x squared, 1 over 1 plus u squared. It's the same thing, right? But u is an unknown function, so I need the derivative of the inside u prime, and that's where the u prime comes into the numerator there, right? That looks like a 1 more than a prime. So every time I do something like this, I'm always going to have another factor of u prime, right, as a multiplier. So it ends up in the numerator. Anyway, y equals arc sine of x gives me y prime equals 1 over square roots of 1 minus x squared. Y equals arc sine of u gives me the same thing, but in terms of u, and then I need a u prime, right? So u prime over the square roots of 1 minus u squared. And we just saw that one in the problem we did. And the only thing that's different about the arc cosine is I get a negative. So arc cos of x gives me y prime is negative 1 over square roots of 1 minus u squared, x squared. And then y of arc sine of u will give me y prime equals negative u prime over square root of 1 minus x squared. And it's kind of that same thing, right? When we're taking a derivative of cosine or arc cosine, we get a negative. Jesse, yes?
Thank you, Robert.
Yep.
It's going on my formula sheet.
Yes. And you want everything on there, right? You want inspirational lyrics for when you get nervous, right? I had a student write on the top of her test, she used to write, or her formula sheet, I am the best, I am the greatest, I'm gonna destroy this test.
Nice.
Perfect one up soon. There's one like this on your test as well. Go ahead.
But so what's the sine instead of cosine for the last one?
Oh, because Robert is rushing ahead to tell you about this little trick, and he's thinking of everything. And that's where we make our mistakes, right? We don't want to be rushing. After you do something, go back and check it, right? Does Robert do that? No, but don't do what I do. Do what I say, you know.
Could you please go back to the last problem?
Yes, of course. Oops, there it is.
Thank you.
You're welcome.
Professor, we did the when we introduced each of the formulas, before we introduced the formula, we did the X version of the problem, and
yes.
That would be in the coordinates, right?
Yes.
Right.
Yes. Which one are you thinking about, though?
Any of them really. I was just wondering if we would come to one where we have to prove it on the test without before.
No. I'm not. I've asked that in the past, but I didn't ask that on this test. You don't have to prove anything. In the past, I've asked you to derive the derivative of the arc cosine right? And I mean, right? Think about it. We don't know what it is, right? We don't know what this derivative is. We'll pretend now we know, but so I don't know what it is, but I don't think in arc cosines. I think in cosines. So we switch it, right? We do cos of y is equal to x, and then I have a triangle, right? Cos is adjacent over hypotenuse, right? And you can already see where the derivative is going to come from there, right? You can see all the pieces of the derivative there in that triangle.
Yeah.
Yep. And so then I take a derivative, and where do I get the negative from? Well, derivative of cosine is negative sine. So I get a negative sine of y times y prime. And remember, my angle here is y, not y prime, just y, right? And so you can see I'm going to get a y prime as negative 1 over sine, and right? It's almost instant at that point. But I'm not asking that on your test.
Okay.
Yep.
And also the questions I sent you.
Yeah.
I highlighted the actual. It's all from the review, so I highlighted the problem parts in red because I would follow through with my work, and then the deep one part that trips me up.
No problem. No problem. I get it. So meaning, on the first one you sent me, you got a red box, and the issue is right after the first line of the red box, right? You have the second line, but you don't know how I got to the third line. Am I correct in that?
Yeah.
Yeah. So I want to do it from the beginning anyway, if you don't mind, just because to let everybody see.
Okay.
Yep. I'm sorry, Chiamaka, did you get enough time there with that one?
I have a question.
Thank you. Yes, Pedro.
The green U is always different. Yes, the green box that we have U.
Yes, you gotta. Once you see that you're gonna apply this piece to your derivative, you gotta then think about this as being U, and it will be different. I think there was one in the homework where U was like horrible, like 1 minus 2x or something, and you had to FOIL it out, and it's not going to be like that. There's not one like that for me. So I try and make all the problems turn out to be pretty, because often as we are as students, we'll go, oh, that doesn't look right. Right? You often will have that, or so I try and create some problems that are not too ugly.
Try and reserve the evil questions for the 400 level class.
Yeah, well, also homework is okay because there's no.
That's true too.
Yeah, there's no. You can always go do a problem on Symbol Lab, and then you'll know you have it right, or
Yeah.
Okay, this is a problem from Afsoon. So far, both problems are very good candidates for the test. Of course, everything we did Monday is also very possible. I like this one. This is one of my favorite problems. So sine of x plus y equals x. And I want to find y prime in terms of x, right? So what's hinting that this is implicit?
The y and the x are on the same side.
Exactly. Y and x are talking to each other, and they kind of can't escape each other. Well, actually they can now. I could do an arc sine of both sides here, right? And get the y to free itself. So this one's not horrible to try and do explicitly, right? But I want you to do it implicitly. So I already have a triangle. Whatever alpha is, whatever my angle is, sine of the angle is x. So the opposite side is x, the hypotenuse is 1, and the remaining side is square root of 1 minus x squared by Pythagorean theorem. Does anyone need to see that? I got 1, 2, 3, 4, 5, 6, 7, 8 cameras off.
Yes, I want to see that.
You want to
Because,
see the
like,
Pythagorean theorem? Sure. So Pythagorean theorem is, let's pretend I don't know this side, but I still have this side and the hypotenuse, right? So I know once I have a right triangle, I have a squared plus b squared equals c squared. So in this case, a squared plus x squared equals 1. Thank you, Noel, for turning the camera on. So I get a squared plus x squared equals 1. So I get x squared equals 1. Oh, sorry, I'm solving for a, right? So I get a squared is equal to 1 minus x squared. And then I take a square root, and I get square root of 1 minus x squared. When I take a square root, I need a plus minus, but you know, you should kind of know that, no problem. You should know that, but it has to work for your test, no, right? You should know that all of my trigs and inverse trigs all happen in quadrant 1. So I'm really pretending I'm always in quadrant 1 in this case. It's a little abstract to think about that, but I just want to deal, if I'm building a triangle, I want positive sides of the triangle, right? That should make sense, right? So I don't care about the negative square root. Does that make sense what I'm saying here? All right, so I've got everything I need here, and that's really just this, right? This is me doing my side work. And I like you crossing out side work unless you want me to grade it, right? It's just for you to figure out. You could always use a piece of scrap paper and then not even include it on the test, right? When you're doing homework, if you do side work on it, you should rewrite the homework problem, right? So we're ready to take the derivative now. So d dx of sine of x plus y equals d dx of x, right? So derivative of sine is cosine. Keep the cat in the box. And then take the derivative of the inside. So I'm trying not to rush, right? So I could do this one pretty quickly because I've practiced it so many times. But I like to put a little placeholder on there in case there's something else more complicated. But the right-hand side is 1, right? So I'm just taking a moment to look at my work, make sure everything's right. Oh, did I do my derivative right? Yes, when I take a derivative of sine, I go to cosine without passing the negative, right? So now I'm doing the derivative of that inside. Cos of x plus y is equal to 1 plus y prime. Is everyone okay there? I'm solving for y prime, so I'm going to divide by cosine. And of course I could rename that secant, right? I could rename it secant. I mean, it looks just a little prettier. Certainly less pen strokes, right? And now I'm subtracting 1. So y prime equals secant of x plus y minus 1. So I would say this is solved in terms of secant. I certainly could have it solved in terms of cosine. Most likely I'm just going to have you solve it in terms of x, and that's what I want on this one, right? So I need to get the secant from the triangle. Where's my triangle? There it is, right? So secant is going to come from here again, right? So y prime, oops, is 1 over square root of 1 minus x squared minus 1. This is a perfectly good answer, but I want you in the habit of, if you have more than one fraction, get me a single fraction, right? So I'm going to use an LCD here, right? So the first fraction has an LCD of square root. I need the second fraction to have the same, the denominator, same denominator, right? And so there's my nice answer, final answer. 1 minus square root of 1 minus x squared all over the square root of 1 minus x squared.
Professor, I
Yes.
was a bit confused here. Like we have secant x plus y here.
Mm-hmm.
We think that like we say that it's like secant x and get like use the formula or what?
No. The secant of x plus y is secant of alpha, right? Secant of x plus y is secant of alpha, and I get that from the triangle.
Okay.
Yeah.
Let's write that down because I don't remember the trig.
Yes, trig will haunt us. For the engineers, it will haunt us forever. So we have to learn it. For computer scientists, if you're going to be doing any kind of robotics, you need to know your trig, right? Cosines tell you to move this way. Sines tell you to move this way, right? So any kind of robotics.
Signal processing
Yeah.
as well.
Uh,
Well, because there's phases. I don't really know.
I can't. Let me, Yes, I can use sines and cosines as on-off switches. So if that makes sense at all, right? Sine of 0 is 0, cos of 0 is 1. So
Yeah, absolutely.
Yeah.
Circuitry, certainly.
yeah. Afsoon, what's up?
So the next one I sent you isn't highlighted, and that's just the whole thing I had a question on. But we kind of went over it at the beginning of class, so we're good with now.
Okay, you sure? You sure? Oh yeah, because that's right. That's the one I almost did. No, that's the one I did, right?
Yeah.
The third one is not on the test. Okay. So the third problem is not on the test. But Delilah asked about that one as well. Chiamaka, thank you. I got your questions. So if I have y equals x to the x, and I'm going to take this derivative, I need to get that x out of the exponent, right? So I take the ln of both sides, and I'd get ln y equals x ln of x. This is what I call the ln trick, where I'm going to try and get an exponent to come down. We're going to do this in Calc 2, okay? So I'm not too worried about doing it now. We're going to do it definitely in Calc 2, whoever you take it with, okay? So it's not on the test. I'm just trying to make things a little easier by removing some material that I don't have to test you on, right?
The actual math was fine. I think there's a rule that confused me. Like, we went from 1 plus ln of x to ln of e to the...
Yes, so it depends on who you had for pre-cal. If I have 1 plus ln of x, I can see that 1 is ln of e.
Yes.
And now I'm summing two logs with the same base, so I can create the ln of a product.
Okay, cool.
Yeah.
No, thanks.
But there should be really nothing like that coming into play on this exam.
Professor,
Yes,
just
Peter.
so I write everything right, correct, the formula sheet through, so I remember the table. So like I have like any trig and in parentheses x plus y as like the last step.
Send me it. I'll look at it.
Okay.
All right. Soon you had sent me another one.
Yeah, there's the last one.
And this one I put on a quiz for my other class. They're taking quizzes. You are taking chapter tests. So they have quizzes and a midterm and a final. You have chapter tests and a final.
The derivative part was fine. It was the critical value section.
Yes, good. So I've got y equals cos squared of x minus sine of x. Nice to get a picture of this, okay? And I'm interested in 0 to pi. So it's really nice to get a picture of this. Let me do it on my calculator because that's what you'll have on your test. Okay. So I'm going to open my calculator here. Yes, my desktop is a mess.
Mine works, Professor.
Oh, really? It's pretty clean.
So I want to graph y equals, what was it? I forgot already. It's cos squared. So I do cos of x times cos of x. I'm sure there's a way I could do, just never bothered figuring it out. Minus sine of x, correct? Sorry. Yes, minus sine of x. And I like zoom trig. When I'm graphing trigs, I like zoom 7. When I'm graphing anything else, I like zoom standard. Okay. I try and
Will that just enter basically tables or the x brackets are
our
values
pi's,
of pi?
yes, our values of pi, exactly. So I know I want a window from 0 to pi. So that's what I'm going to do, right? So I'm going to change my window. I'm going to change my x min to 0 and my x max to pi. So second pi. And then enter. And then graph. So this is the picture I'm looking at. And you can clearly see, so I'm asking about critical values here, right? At the endpoints, you can kind of see slopes like this, right? But at the center of it, you see a horizontal, right? So that's really, so the graph will give me a nice picture of where the critical values are, right? I'm looking for the top of a hill, the bottom of a valley, or a really steep, right, undefined slope, right? So I think I'm getting, remember my scale goes from 0 to pi, so it looks like I'm getting a critical at pi over 2, right? So let's go back to my my piece here and let's do this derivative. What's the outside function here? What's the overall end thing that I'm going to do? What's at the end? What am I going to do? Or if I'm right, what's the big picture that's happening here? It might be better if I write it like this. Right? Those two cos squared of x and cos of x quantity squared mean the same thing. Okay, so but you can see that the big picture here, the outside function is a square, right? So when I go do y prime, I have to do 2 times.
It's going to be the derivative on the outside and the original on the inside.
Good. So what do I get for my derivative on the inside?
Negative sin x.
Yes. And then the derivative of negative sine is negative cosine. Everybody okay there from line 2 to 3? Nice. So you can see I can factor out a negative cosine. And that's the idea. When you're going to get critical values, you want things to be factored. And it looks like I have 2 sine x plus 1 left over on line 4. Is everybody okay there? Thank you for the cameras. We're down to only 4, and I've got 1 camera's not working. Sorry, a second. I forgot to read the chat.
Professor,
Yes.
where does the 1 come from?
Good. So if you see that if I distribute this cosine back, do you see the cosine times 1 gives me that cosine up here? So
Okay.
yeah, so when you factor something, make sure you distribute it back in your head or on paper just to make sure you've done it right, right? And I know factoring is an issue, right? Factoring's an issue. So be careful with it. So now I want to find where my factors are 0, right? So I want to find negative cos of x equal to 0, or 2 sine x plus 1 equal to 0. Oops, that's a sine x, believe it or not. Right? So meaning I want to find cos of x equal to 0 or sine of x equal to minus 1/2. I do this quickly with a picture first, right? So cos of x equal to 0, right? And then sine of x equal to minus 1/2. So, but remember, I'm only in quadrants 1 and 2, right? I'm only from 0 to pi, right? So I only care about that piece, right? The minus 1/2 over here is coming from here and here, quadrant 3 and 4. So I don't care about those, right? So the only one I see is x equals pi over 2. That's my only critical value.
Professor, can you repeat the quadrant thing you just said?
Yes, so remember, when we graph our cosine and sine curve, we're in 4 quadrants, right? Right? So you can see, because my interval was from 0 to pi, right?
Oh, okay.
So I don't care about anything. I only care about the pieces, so the 0 that I get there, or the minus 1/2 that I get here, and I don't get any because sine is above ground in quadrant 1 and 2.
Okay.
Yeah. Yep. Nice. All right, Chiamaka sent me, looks like 3 problems. And they're all derivatives.
Oh, no, it's 2.
Oh, yes. Yes, it's 2. Yeah, D and E, yes. Sure. So that's fine. I like these. Let me do D first. So I've got y times ln of x plus y squared equals 0. So this one is implicit. I can't solve for y. If I factor out a y, I still have a y stuck with an ln. So I'm going to just do it with implicit, right? So this is a find y prime, right?
Professor, the ln can appear on this exam, like in this
Yes, I
type
can
of-
put ln on the exam, but I'm not going to put the ln trick on the exam. You know the derivative of ln, right? If y equals ln of x, y prime is 1 over x. And if y equals ln of u, what's y prime?
ln.
It's still 1 over u, but I need a u prime, right? So u prime over u. So I did put an ln on the midterm exam for the other class. And they got mad at me when I started reviewing with ln problems, but come on, it's from pre-cal. All you need to know now is the derivative, right? Anyway, I have a product rule here. So y,
For the second equation, it would be the same if it was in terms of u, right? If I'm not mistaken.
so the key in both of these is that I'm taking the derivatives with respect to x. Right?
Yeah, that's what I meant.
Yes.
So if it was in terms of u, it would still be the same.
Yes, but u is a function of x.
Yeah, that's what I mean. If it was d over du.
Oh, it's d over du. If it was d over du of ln of u, it's 1 over u. Right? Because it's behaving like an x. U prime is 1. Now, in this case, u prime is 1, right? Yeah.
That's what I meant.
Yep. Good. So I have a product. Yes, Pedro.
The only way that, just so you know, this is the most probable way that ln will appear on the exam, yes?
One more time. I didn't quite get it.
And there is no ln trick and things like that. Ln will just appear find the derivative, find.
Yes. Straightforward derivative of an ln if it's on the test at all.
Okay, I will write this down. Thank you.
Yeah. So y and y prime, ln of x and 1 over x. There's my product rule. right? So this is my little side work here. So I'm ready to take my derivative, right? And what do I get? I get y over x plus y prime times the ln of x plus 2y y prime equals 0. Make sure you see that, Chiamako, make sure you see that I'm getting the first piece from the product rule, right? I'm doing the product rule of this green piece, right? And then the derivative of y squared is 2y y prime, right? This is implicit, right? Everything okay there? Nice. So on this one, I want to solve for y prime. So it looks like I can just move my non-y prime terms to the right. So y prime ln of x plus 2y y prime equals negative y over x. Right, so I moved the non-y prime terms to the right. And now I'm going to factor out my y prime. I get ln of x plus, I get y prime times ln of x plus 2y still equals negative y over x. And now I'm going to divide by that. So final answer is y prime equals negative y over x times ln of x plus 2y. And that's about as nice as it can get.
Professor?
Yes.
Yeah. So that's the answer I got, but in the solutions it was positive. So that was what confused me.
And what section of the book is that?
The review material.
Okay, in chapter 3.
Yeah, review.
That's right. You should probably check when you factor for costs. I think that was I'm not mistaken.
You're talking about the earlier problem, no? No, you're talking about the earlier problem, right?
Yes, right.
Okay, let me go back to that in a second, okay? I'm trying to see here how I could possibly have a positive out of this. I can't see it. I can't see it. I'll look at the book, but I can't see it. Sometimes the book makes a mistake. I mean, we're all human. Nothing's perfect. The sooner we accept that, the easier life is. All right, let me do the next one on your list there, Chiamako. I like this one a lot.
This is refreshing because it's all the stuff that we went over Monday.
Yeah, there's nothing wrong with extra review. When we take our final exam, I review a whole week. I review Monday, Tuesday, and then Monday, Wednesday, and Friday. Nice, so product rule here, but the arctan has got a chain rule, right? So my first function is x squared. My derivative is 2x. My second function is arctan of 5x, right? So I need to be thinking about u prime and u squared, right? So I'll do that on the side real quick before I do my derivative. So u is 5x, u prime is 5, u squared is 25x squared. So my derivative here is 5 over 1 plus 25x squared. And I'm doing a product rule. So y prime is, so Chiamako okay here? Good, so y prime, it looks like 5x squared over 1 plus 25x squared plus 2x times the arctan of x. Sorry, arctan of 5x. Now, there's no way to get this to be prettier. So I try and not give you one where it doesn't make sense to make this into a single fraction, because where we're going in chapter 4, that's what I need. Okay, so I'm really kind of trying to get you ready for chapter 4. So I don't see myself giving you one like this. If I did make this into a single fraction, look how ugly it gets. So I'm going to multiply this by 1 plus 25x squared over itself, right, to get the LCD. And then, so now my final answer is just hideous. I've got a 1 plus 25x squared downstairs. And upstairs, I can't do anything. I've got a 5x plus 1 plus 25x squared times a 2x arctan of 5x. The arctan is getting in the way of anything else happening. See, from this I could possibly factor something, but it's just it doesn't make any sense. It doesn't make sense to do it on this one. But I'm trying to keep things like that off the test.
Oh, I just have a question. So you won't need a triangle for this type of problem.
Correct. This one I don't need a triangle for. Like if I just gave you y equals cosecant of x, all right, I have a trig, but I don't know the ratio here, right? I need a ratio to really need a trig. And so there's nothing wrong with you going, okay, if theta is arctan of x, of 5x, then tangent of theta is 5x, right? And then my triangle, I have a 5x and a 1, and I have a square root of 1 plus 25x squared. But you can see that it never comes back into play again. I don't need it, right? If I look at my answer here, remember I need a trig to go back to the triangle, not an inverse trig.
Yeah.
So the inverse trig goes back to theta, but I don't want to do that, right?
Okay, thank you.
Yep. And like I said, so you can always draw the triangle, but 90% of the time you need it. All right.
See, you usually need the triangle for one in terms of x, right?
Yes, exactly. Yeah.
And this one is just straight, get the derivative.
Exactly.
Which part is the answer on this problem? Is the cosecant x?
One more time.
Which part is like the answer? Like which part I would box and say
The first black box.
Oh, okay.
I did then get an LCD, but it's ugly. It's a mess. And the whole thing is the pen strokes, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I'm trying to write as little as I can, so I prefer the first answer in this case. Let me look at the exam I made again for Friday. Make sure there's nothing else on here that I want to talk about. I did this already on Monday. When you were all asking me questions, I made sure I looked at, what I'm putting on there. And I did give us a list, didn't I? Did I give us a list for Friday?
Yes, you gave a rough list with 8 problems.
Yeah. Good. Who's got my list? Someone read me the list again. I want to make sure because I think Nahom wasn't here
Let me see.
on
Yeah.
Monday, but I did record Monday, right? So
Yeah.
I gave a list.
Yeah,
Who's got?
I have a screenshot.
Yeah. Will you put it in the chat?
Sure.
I know it's like I can say it's like the
Let me get that really quick.
Okay, the first one that you wrote was derivative of a limit. Checking.
Yeah, no.
both-
Pedro, it's fine. He's going to put it in the chat. We'll open it and look at it together. Thank you, though.
See how long it takes to load.
We're in no rush. We're ready for Friday, right? Are we psyched? We psyched for Friday?
Seems like it.
What do we learn from the first test? What are we going to do different on the next test here? Anybody suggest?
Pray more.
Breathe more?
No, pray.
Oh, pray. Both could help. Breathing is important. And when you get nervous, you stop breathing and then your brain starts dying. So I don't know how it's going to do calculus. Write fast. Write constantly. Write fast. Ask questions. No one asked questions last time. Right? Use your formula sheet. Make sure your formula sheet is complete. What kind of file is this?
PNG. It's a MS Paint file.
Oh, God. Can you put it up as something else?
Let me see.
Let me see if I can I can't open it. Can anyone open it? Here, Jesse, I'm going to make you co-host. Just share your screen for me, okay?
Okay. Let me get that then.
Make your co-host now. You should be able to share your screen. Let me unshare mine. Oh, so right now you should. I'm going to unshare mine. And now share yours, please.
I'd like
Okay.
to this file. You need to download it, and like I was able when I loaded it in downloads.
Jesse, do you see yourself being able to share a screen? You
Yeah.
see it. Middle button, green, middle button. Here we go. Nice.
Very good.
And scroll on that for me. Beautiful. Yeah. So derivatives as a limit, right? Like test 1, right? Like our first test. Chain rule problems, product rule, quotient rule problems. Go ahead, scroll for me. Implicit differentiation, we did a bunch of those, right? Trig tangent line. I'm probably not putting L'Hopital's or continuity on. So 7's probably going away. So that's it. That's it. We're ready.
And then said inverse trig derivatives where you need the triangle.
Yes.
And yeah.
Yep.
Obviously, we're going to need that.
Like I did today. Yeah, exactly.
Yeah, this is just ln stuff.
Mhm.
Yeah. Okay. Cool.
Nice. Thank you for doing
Cool.
that.
Got it. Is everybody good?
Anybody need to say anything there, or I've got it.
Oops.
I've got it. So
Okay.
thank you.
All right. Cool. Thank you.
So I don't know about you, but I'd like to go have breakfast. But if you've got anything else for me to answer, I'm happy to. I can't wait to see what you do Friday. I know the test is more difficult, but I think you have a better feel of what to be ready for, right? And you have done all of my chapter 3 tests, and you've done all of my midterms, right? So you know as difficult as it can get. I really don't see this being any more difficult than any other thing, than anything I'm putting on this test. Will there be 1 or 2 problems that make you go, what? Yes, but what are you going to do? Graph the function, maybe, try something, do a free write, right? Go on to another problem, right? If you have a mistake on something, and you don't know where the mistake is, try the problem all over again, right? Yes, Satsun, what's up?
Yeah, what do you mean by, like, ask questions? Because in my experience, it's been like you take the test and then you ask a question and then they're like, you can't ask that question. So
I'm not like that. I'm more of a, well, did you draw a triangle? You know, I'm more of a yeah, I'm not. I'm nasty in real life, but during a test, I try and be kind.
What type of questions other than asking the answer we can't ask?
Is this correct?
Oh, that's the type of question that I like.
Can you send me some money? Actually, that one I can't answer. No, I can't send you money. So I'm psyched to see what you do, right? You're doing great work. I really appreciate everything how you've been working and how you've been participating. You know, I hope you have a great spring break. I should have grades for you because I'm going away. I'm going up to see family, God forbid, for spring break. So on Monday, so I'm hoping to get everything graded before Monday and sent to you. Okay, I'll soon. What's up?
Well, first, have fun on spring break. Second, will we get our homework 5 before the test?
No. So what I did for homework 5 is if you handed it in, I gave you 10 out of 10. So I gave you 10 out of 10 for section 3.3, 3.4, 3.5. But if there's something on there you want me to do, I'm happy to do that.
Okay.
I'd say Monday we did a whole bunch of them.
Yeah.
So I think we're okay. Go ahead, Nahom. What'd you say? Nahom?
No, I said God bless you for that, Professor.
Oh, by the way, so I've already got my grades almost done. I'm just waiting for your second test. But I'm dropping 3 quizzes. I'm sorry, dropping 3 homeworks. And I've got the extra credit in there. So you're going to see something like a min ABC grade, right? It's gonna tell you basically what you need. If your test average is going to stay the same, okay, what you need on the final to get an A in the course, or what you need on the final to get a B in the course, or what you need on the final to get a C in the course. Okay, it's not meant to scare anybody. It's meant to show the students with who've been doing everything how easy the final exam will be to keep your A or to keep your B or to keep your C. In the final exam, go ahead.
I had a middle school teacher that used to work as a professor, and he talked about that. I remember something like that.
Yeah, but the final exam is always really straightforward for me. I just take all of the problems from your earlier tests that you couldn't do and put them on the final. If not an exact version, a slightly different version. So that you can say now, oh, now I can do it. Now I get it, right? So, again, trying to make it so that if you finally get it now, even if your final average is a failing grade or a D, but your final is a C, then I can easily give you the C. I don't care about whether you pass this class or not. I care about what happens in Calc 2. That's my job, is to get you ready for Calc 2. So,
yes.
Yes.
The final exam, especially I had like a math teacher. She used to basically say study everything, and then she used to give us like 4 problems from everything, which was like really hard to study for, because you had to study everything in like very specifically. So like we'll get like directions as we get with the test, right?
Yeah, I would say if you can do everything, you're fine. So she went to the same evil teacher school as I did, I guess.
No, she basically said, like, with no directions or like nothing to focus on, just study
Yeah,
everything.
I would say we're going to have 4 tests. I'll take 3 questions from each test.
Yeah.
Yeah. So, but the ones that most people got wrong. So maybe you got them right. So you're not worried about it. So you're just really going over your old tests, right? And I'm going to review for a week. So it
sounds like the final exam is no SATs exam.
No, it's going to be repeats of what you couldn't do during the semester, so that you can now show me you can do it. Right? And then for some
Absolutely.
of you already can do it, so you got nothing to worry about. Right? Just trying to give one extra chance.
I can't wait. Can't wait to go on the final test, and it's solve this using the limit x minus h definition of the limit. And it's like
That will be on. That will be on there. That will be on there. It will be on there.
That's a gimme. That's what
Exactly.
my high school math teacher would call that problem, is a gimme.
Yeah, well, the first
So
question
easy.
is always a gimme, where it says name and there's just a blank space. You know, that's
Yeah.
Don't copy
That
that
one's a
one
gimme
from
too.
anybody. All right, let's go to breakfast. Have a great day. See you Friday.
Thank you, Professor.
Thank you.
Nice day, Professor.
Thank you. You too.
Right.